So, hello everyone, thank you all for coming to my talk. I'm super excited to start my session. So in recent times, everyone, either it is a startup or it is a big MNC, everyone is transforming toward the AI and large language model like a ChatGPT and a Gemini and trying to implement the AI solution in their project or in their product. So my talk is related to that. Creating a model is one of the part, but how we can deploy it in a production, like what are the best DevOps practices we can see. For this, I have created one small application of the large language model, and we can see how we can deploy it in a production. So before deep dive into the world of large language model and deploying in the production, let me introduce myself. My name is Niket Ranjan. I'm an Associate Software Maintenance Engineer in Sustaining Engineering Kernel Space at Red Hat. I have almost 2+ of year experience in different domains like DevOps, cloud, like AI, or like development, QE, and got opportunity to work on different DevOps tools and hybrid cloud platform. So what we are going to discuss today. First one is the use case, problem statement, what we have. Then we will talk about the proposed solution, and we will see like what we are building, a small trailer kind of thing. I will show you the real-time demo, how things are working, and then we will start talk about some basic introduction about the large language model, different architecture of the large language model, and we will see full details architecture, end-to-end cloud native LLM flow. Then we will see about full detailed demo of that application, how we have created from the scratch, and how we are deploying in a production with the DevOps practices. And we will talk about some production grade features you need to ensure that. And then I will share with you all the resources and everything. And at last, I will take your questions. So documentation is everywhere. And this documentation is if this documentation is for any organization, it's very critical. And this documentation some certain workflow, some kind of internal tools or internal docs we have. So that contains some kind of sensitive or internal data. And suppose if we have some kind of newcomer come, in the first week of the day of that newcomer, we generally share some bunch of documentation to them. And reading the documentation one time, it's very easy. You can go some hundreds of pages one time. But if you repeatedly you need to go through that documentation, it's sometimes slow and frustrating. And if you have some kind of a tool you use daily and some kind of a workflows, you just need to go and see the commands and everything, it's sometimes frustrating. And we are the world of the ChatGPT, Gemini, where everyone is the race of creating their own large language model, and they are using and in their project or in their product. And this documentation we can't upload to the public LLM or a public world because they may have some kind of sensitive or critical data. We don't know if we upload and how they are going to work. So what is the solution we have? So we need some kind of a secure, private, and cloud native approach to create some kind of a LLM model with different architecture, how we can train to query on our sensitive documentation. Like our employer, anyone they can easily chat with their internal documentation, and they can easily train in a real time. And all the data will stay in your network. No data will be over your network. Everything will be in your infrastructure, so it will be very secure. So what we are going to build? This is the small demo I have created, how things are going to work, and then we will build the solution. This is my front-end UI I created using the Next.js, and now we'll ask some questions, few questions. I will ask about myself. Who is Niket Ranjan? And this is the untrained model right now. They do not have any answer. And now I will ask what are the skill set of the Niket Ranjan. Then again, they do not have any answer about this. And this is my documentation I have created. This is sort of my resume where I have my profile summary and my education, my technical skills, and where I have worked on everything and which team I'm currently working in Red Hat and everything. Now I will upload this documentation to the Google Cloud GCP bucket. And then we will see how things are working internally behind the scene in real time. So this is my documentation. And now I will upload this documentation. This is my GCP bucket that is currently empty. Now I have created one script to upload this file. So one PDF file has been found. So it will now the PDF has been uploaded and removed from our local system. Yeah, so PDF has been uploaded. Now we will go, when PDF has been uploaded, the pipeline gets started, and for this I have used this GitLab, and then the pipeline gets started, it will pull the documentation, and they have multiple stages and train the model. So if you see, this is my self-hosted LLM server where my LLM is running on our own infrastructure. It will download the documentation, and now I will ask, who is Niket Ranjan? So they answered, Niket Ranjan is Associate Software Maintenance Engineer in Red Hat Sustaining Engineering. Then I will ask, tell me about the sustaining engineering. Then they will ask, like, sustaining engineering, we work on a different RHEL, downs like previous version of RHEL, and fix some CVs. And I will ask, like, the skill set of the Niket Ranjan. And I have created some features, like if you see in ChatGPT, some kind of a prompt response, like some suggestion prompt. So there are different sections I have created. So it is also working here. You can get some like prompt suggestion from this LLM model. So let's build this. Like suppose we are the user, everyone is using the AI, so like a LLM model like a ChatGPT, Gemini, but we can create something like that for our use case. Like we can open this, how ChatGPT and things are building behind the scene, and we can create something to, like, create something for our own, some in our organization either, or for personal use also. So suppose this is the cat I have used, and this is your large language model, you can say, and this is the internal documentation inside the truck. So these all the different documentations you have, and yeah, you can directly ask to that. So basically, what is large language model? So large language model is an advanced deep learning model trained on a massive number of a data set that understand like a human language, think like a human, and they give some kind of a solutions to us. For training the large language model, we have different level of architecture. First one is the prompting. You can directly interact with the large language model using some text prompt, like you are already using the ChatGPT, and we can train our model. Second one is the RAG, Retrieval Augmented Generation. That combine LLM model with our external data and create another model, and we can easily store into the vector DB and prompt that, and it will work like give the accurate answer and everything, like internal knowledge board, QA system. And third one is the model realignment, where we are trying to retrain our model from the scratch that needs some kind of huge amount of research. We need huge amount of computational resources, huge amount of a data set. This is the biggest challenge. And we can train our model, and it will take lots of time, and it will be a very specialized kind of a tool. And let's understand large language model in very layman term. If we have a dog, so generally we train our dog in like some kind of a basic training, like come, sit, down, and stay. These are the basic training we give our dog. But if we want some specialized kind of a dog that work as a police dog, army dog, watchman dog, or a guide dog, so we give him some kind of a special training to dog. That is referred as a large language model. And for our use case, we are trying to automate our internal documentation thing. So RAG will be very beneficial. RAG is very beneficial for us. So RAG is stand for Retrieval Augmented Generation. That is the one of the AI framework of the large language model. We train our model with combining with our external data sources to generate some more kind of accurate answer and the relevant answer. In this diagram, you can see directly you can query to the large language model. It will go and it will store some kind of a chunks in their databases like vector embedding. And if you ask some question, they will combine both of them and they will answer you. So application of large language model like question answering system, a specialized kind of a chatbot or a virtual assistant. And next, what are the steps how we can build this large language model? What are the steps? The first one is the plan. First one, we need to ensure that what kind of a use case we are trying to solve, like identify the problem, then choose the LLM. So you can choose the LLM, like it should be open, like you can use open source LLM, either a closed source LLM. Open source LLM like you can use the Llama, InstructLab, this kind of LLM, and closed source like ChatGPT, Claude. They are having some API, and that are the paid models. And we can customize the model according to our use case. We can use different frameworks of the training we have seen before, either a RAG, either a model realignment, either a prompt engineering. After that, we need to set up the architecture, how we are going to serve this model, and we are able to access either in a chatbot or either in a kind of a UI application you have seen. and then we need to implement and continuously feedback how we can improve this solution. Next, this is the high-level architecture, how we are going to implement today. So suppose this is the admin guy who upload this PDF to our Google Cloud bucket, or these PDFs are manually uploaded from one of the servers you have, or either you can, this PDF like documentation on a Confluence, and you can just through the REST API or something, some kind of a service, microservices are running, they can upload the PDF to this GCP bucket, and there is another cloud function running on a Google Cloud. It is called as a file watcher service. It always look at the GCP bucket. When new PDF will become, it will auto trigger. And then GitLab pipeline. This GitLab is a self-hosted. I have used the GitLab because GitLab is an open source first of all, and it gives the capability where you can run your own system as a runner. So it will save your cost if you are going to the cloud or anything. And this GitLab MLOps pipeline having two stages. First, it will pull the documentation from the GCP bucket to your server where LLM is hosted, and then update the context. Means this will execute some RAG code. It will update the context in the RAG, like loading the PDF, extracting into the chunks, then vector embedding, stored into the vector DB, like I have used the Chroma DB. And then like you can use this and expose this as like API. You can expose this, and I am using the Kubernetes cluster that is in a public world. We all, like you guys all known that in a basic concept of networking, if you have some local kind of system, they can't go to the public world. So you need some kind of a public IP in that system, or like you can go to the cloud and get some VM. So for now, I am using the self-hosted LLM model. So for this, I have used the ngrok tunnel to expose the API, and then I have deployed, containerized my front-end application, created the CI/CD pipeline of that, and deployed it through the pod, and then exposed as a load balancer that user can easily able to access that application through the load balancer. And everything is managing by the Terraform, to automate the infrastructure side on a Google Cloud. And there is also another infra pipeline that will create the resources in a few minutes. If one team you have, it is okay, but if we have, like in organization, 10 teams want to their own infrastructure because they have own documentation and everything, they can create by using this Terraform. So this is the full detailed demo where I will show you. This is the untrained model. I have used the Olama L3.1 with 8 billion parameter. Then I will ask some basic questions. For this demo, I have created one fictional kind of a company named TechFlow Solution. In future, you may create, and they have some kind of HR policies, tool created, documentation created, everything they have. And now I will ask some question that they don't know right now. So they do not know about anything about the TechFlow solution. Now this is my GitLab runner that is running on a self-hosted, and these are my documentations. You can see this is the details about the TechFlow solution, when they founded, where is the headquarters, who is the CEO, CTO, finance, everything about the TechFlow solution. And this is the HR policy of the TechFlow solution. And you can see everything, what any organization having some HR policy and everything. And this is the one of the cloud services created by TechFlow. Everything is a fictional. And this is the one of the product I created. This is Calculi observability platform. Here you can trace matrices, logs you can get. So this is my Google Cloud account, and this is my Google Cloud bucket. Right now it is empty, and now I will upload this documentation. And this is my Cloud Run function as a file watcher service, I can say. This will auto trigger when new PDF has been uploaded to this GCP bucket. And this is my script I have created. You may use some kind of REST API or something to upload and download script. And this is my RAG API code. This is the backend code where I have used an expose API as a FastAPI. And this is the RAG module I have created. And next, now we will upload this PDF. So you can suppose PDF is running it is kept on one of the server, and you can easily upload. So they found 6 PDF files, and easily they can upload to the Google Cloud bucket. And when they upload, they will remove from the local, so there will be no duplication, anything. So now the PDF has been uploaded. So when the PDF has been uploaded according to the workflow, it should trigger the MLOps pipeline. 6 PDF has been uploaded, so you can see 6 times pipeline has been executed. And here is the real-time log that they auto-trigger the pipeline. You can see the time also. You guess 7:57 when they have triggered the pipeline. It is in a real time. Now again, the pipeline have two stages. First one is the pulling the documentation and dumping into the LLM. And they have downloaded the PDF. And now you can see this is my self-hosted LLM model server. So they have downloaded in their directory. And now I will ask the question using the curl method. So this, I have exposed the API. So I'm for the just testing this model is properly working or not. They are able to answer from the PDF or not. So now I will ask some questions. So I have asked, they are giving the answer, but this is in JSON format. So in like from the CLI, you can see like that. And these are like everything they are taking from our PDF, nothing apart from that. So I will ask next question, who is the CTO of the TechFlow solution? So Michael Rondia. So it is correct. Everything they are fetching from the documentation. I will ask few more questions like HR and the leave policy, because any organization having some kind of HR leave policy, so they will answer. So they are able to answer that. So our model is properly working fine. Now we can integrate it with our front-end application. So this was the part A of the demo. Now part B will be how we can integrate and how we'll deploy on a Kubernetes cluster and a Google Cloud. I have used the ngrok tunnel and exposed the API. So this is I name as the application as a Jarvis. And then this is my pipeline CI/CD pipeline code. And this is the first one is the Terraform code. This is before the CI/CD or application, we need some infrastructure. So for this, I have created using the Terraform. So it will create VPC, subnet, and the GKE cluster on a cloud, and everything is managed by the pipeline. And here is the variables. Nothing is the hard coded. Everything we are getting from this variable. And another one is the backend code here. In a backend code, I am using the provider as the Google Cloud. And if you have work on Terraform, they are maintaining their state. So it is kept on one of the bucket. Either you can put it on a S3 bucket in general, or you can use this Google Cloud bucket. So here they are maintaining their state in this bucket. Now I will manually trigger this pipeline to spin up a new GKE cluster in a few seconds. So you have only one organization, it is okay, you can manually create, but if you have 10 organizations, they have own, so they can use this infra pipeline and spin their own GKE clusters. So if the workflow of the Terraform, first they validate the code, then they plan, and then they execute the code. So they are validating, then they plan, and then they will execute. So this is my GitLab. Again, this is running on my self-hosted GitLab runner. And they will apply now. So yeah, new GKE cluster has been created. If you go to the Google Cloud, and you can see. So GKE cluster has been created, and it is active now. It takes around 5 to 10 minutes to spin a cluster. I have fast forwarded and cutted some scenes to more delay. And there are some nodes. So I have created 3 nodes and some node pools. Some are spot instances, some are on demand. And now our cluster is properly running and everything is working fine. We have the infrastructure spin up. Now we can deploy our application. This is my UI application, and this is my, I will go to the, we in a production or in any when we have a development, we also use multiple stages like dev, prod, or stage. And this is my pipeline where I am building the Docker image and pushing to the Artifactory and deploy on a Kubernetes. So this is my Docker file. I'm using the multi-stage. Always in a production, we should use the multi-stage Docker file. And now I will build this code. As a developer, we are always working on new features. Suppose in a UI, we have worked on some features. I have just changed something, there's one unnecessary file I removed. When I will push it to the repository, the webhook will trigger and it will start executing the pipeline. Now changes has done. Now I will push this code to that repository in staging branch. or everything will be fine if then you can merge it into the production in the pipeline, like if stage is properly working. So I will go to the pipeline section. Now pipeline has been triggered. Now they have multiple stages. First they will build the code on a self-hosted GitLab runner again, and then it will deploy on a production like GK cluster. According to the requirement, you can just change the .gitlab.yml code. If you have some kind of certain like multiple stage branching or anything, you can define over there. And this is the Artifactory. The build stage has been done. Now they should push. So they already pushed the latest Docker image, and they already deployed on a Kubernetes cluster. So we will go and see. The application has been deployed. If you see, I have configured that GCP cluster in my command line CLI. You can see there, and they have multiple nodes. This is multi-node cluster. If we have a single node, that is single node cluster. We have multiple nodes, it is multi-node cluster. And they are like list of the different pods, and the front-end application is running in this pods. And this is the secret they have created, because we need to pull the Docker image from the Google Cloud Artifactory to this Kubernetes cluster, so we need to set some kind of secrets. This is not a public image, that's why. So, and this is the service I have exposed the UI. So this is the external IP. I expose as a load balancer. They can able to. This is the managed service, so they can able to handle the workloads. Now we are able to access our internal documentation UI. Now I will ask few questions related to the TechFlow solution again that I asked to the untrained model. So from the Google Cloud GKE cluster, they are going through the ngrok tunnel to the backend self-hosted system. This is the flow the text data is traveling. And they are able to answer TechFlow solution, company founded in March 2019. Then I will ask about the financial report of the TechFlow solution. So they have some kind of revenue they have generated. And I will ask like some kind of a tools they have developed. So these things are just a fictional. You can create your own documentation either for personal use also. If you have some blogs or anything, you can automate for your own. You are running in instead of a Kubernetes, you can run this UI application in your own and local. You can see they are able to answer everything from the documentation. These are the different tools they have created and everything. And I will ask about again the leave policy and the HR policy, everything. So everything they are going to that vector embedding, and they are fetching information, dump into the LLM, and then they are asking, giving the output. So from the documentation, they found these are the informations. And now, next is the monitoring part. Till now, we have application is deployed, everything is working fine. We need to monitor our own infrastructure also. That if some workload happen, then it should automatically new node spin up. We should get some kind of alert. So this for this, I have used this Google native monitoring tool, Google Dashboard they provided for the Kubernetes. So these are the resources we can monitor. Computational resources, we can just monitor different nodes, different pods and everything. And we can see the CPU limitation. If some nodes having some more CPU, then they should send some alerts. So there should be no downtime. And now in the backend, front-end is front-end we can easily front-end we can easily monitor from that cloud native, but we have the large language model, LLM model. So for this, we do not have any kind of exporter. So this is running on a self-hosted. So I have created my own exporter or deployed Prometheus Grafana in my local system to monitor my LLM model. And we can set some alert also on that model. So for this, I have used the Prometheus client. So this is my exporter I have created. And again, this is the again Dockerfile was running this API. And why they repeated? So when they are starting getting the matrices, so these are the matrices they are getting from the LLM model, like chunks and everything, how many documentation and everything. By this way, I've just, for the demo purpose, I have deployed through the Docker Compose file into my local system, and this is my Prometheus YML file, like about the node exporter, getting about the system API, Olama exporter, and this is my API, where they are getting everything from here. And this is my Prometheus UI. They have multiple node exporter, you can see, and they have Olama exporter, Prometheus. Different jobs they have. They are fetching the matrices from different resources. And this is my Grafana dashboard, where this is the UI application, so UI dashboard, where we are monitoring the LLM server basically. First one is the CPU, memory, and everything about the LLM server. Maybe they can have some they can exhaust resources, so we can spin more, attach some more LLM server, this kind of thing we can implement. So from here we can monitor from the Grafana dashboard. This is open source again, and this again this is the custom dashboard I have created. They are the 8 documents and everything about the documents, chunks and everything. According to your use case, you can create the exporter, what matrices you want, and you need to instrument your API code and everything from where, and you can easily set up the monitoring and logging part. So till now, application has been deployed, and application is easily accessible, and everything is working fine. We need to talk about some DevOps practices. First one is the scalability. So this is the self-hosted LLM. So whenever new PDF came, like on a nightly basis or somewhere, when new PDF came, it should hot reload, auto delete the new PDF files. And if we have some, like one server of API, but if we have more traffic, we should horizontally scale our API server, like server 1, 2, 3, 4, 5, and top of that we can use the load balancer, so they can distribute the traffic. And we can use multiple LLM servers, they can easily handle the load. And second one part is the GKE, where our UI application is deployed. So we should use, for the pod auto scaling, we should use one of the Kubernetes resource, horizontal pod auto scaler. According to the traffic, they can easily scale our pods. And we also need some kind of auto provisioning in node. Like if that node is fully exhausted, then it should auto provision, so we can't face the downtime everything. So we have the Carpenter auto scaler, this kind of a tool we can use. And we should also ensure this GKE cluster is deployed across multiple zones and multiple regions, the same replica of that. So it should be high available. If one region, something happened to one region, so they can accessible in another region. And we have the GitLab pipeline. For now, for my use case, I have used the self-hosted. It should automatically trigger, and the UI deployment is automatically by using the GitLab pipeline. We can use some kind of a deployment strategies like canary, blue-green deployment, create replica of that blue-green, and according to new feature came, so we can deploy the application. We can set some kind of alerts and everything through this infrastructure to get some Slack alert, email alert, or you can integrate with your Slack also and everything to chat with this application and for your use case. Next is the disaster recovery. So here we are using the GCS storage. So we should also always do the snapshot of that, and we can create the backup of those PDFs, vector DB models. And here I'm using the ChromaDB for demo. You can use the Redis vector DB or Elastic Cache vector DB in multiple region in production. And we can also set up some kind of a lifecycle policies, some kind of a versioning, different cross-region replication of those GCS storage. And we can do some store our vector embedding, some kind of a mounted volume, not inside the server, because if server goes down, then our data will be also goes down. We can lose our data. And if we are running in we can use some kind of persistent volume. If we have deployed our LLM model self-hosted in Kubernetes to make it a cluster, we can use the PV persistent volume. And we can also, for spinning of the GKE infra, we are using the Terraform that we have already seen. And if we have some kind of failure or recovery plan, we can rerun the pipeline. Everything will be spin up in a few minutes. And from PDF to PDF from GCS, embedding will be regenerated, and LLM again hot reload everything. And next is the resources. I have created this documentation. You will get everything, all the code and everything. And if you have any question that I can't say right now, do not have any answer, I will write down in that documentation everything you will get here. You can use this in your organization, either for the personal use, and you can connect me on a LinkedIn if you have any idea how I can improve this or anything, so we can connect on a LinkedIn. And do you have anyone having question, they can easily ask. I will try to answer you. Yeah.
The Google Cloud that you showed, is it paid? How much did you pay for it?
So for now, this is, they are like Google Cloud is paid or not, what I have used. So if you want to learn anything on a Google Cloud, they will give you some 300 credit for 30 or 60 days. So for practice, you can use the Google Cloud and everything. In AWS also, you will get some 12 months free resources, 750 hours per month, I guess. That you can use easily. They are giving some kind of credits for initial days. Or suppose you have exhausted the days, you can just create one kind of a query or a ticket that for the practicing I'm using this Google Cloud or anything resources, but I'm a student or I'm a beginner, so they will waive up all the bills and everything.
So you get it for free?
Yeah. Anyone having another question? Okay, thank you everyone.